Hello students, today we are going to learn about the structure of human heart. Our heart is the chief circulatory organ in our body. Heart pumps the blood throughout the body and receives the blood from the body also through some blood vessels. So here we have to note it down. In circulatory system, not only heart, even blood vessels, blood is also involved in the circulatory system. Let's begin with the structure of human heart. Our heart is hollow and it is muscular, and moreover it is conical in shape. You can find it is conical in shape, and it's a pumping organ that pumps the blood throughout the body, and its size measures about 12 to 9 centimeter in size. It's just a clenched fist size, and it weighs about 300 grams in the case of males and 250 grams in the case of females. Where it is located? It is located in the mediastinum. Mediastinum is nothing but it is in the center of the thoracic cavity. In the thoracic cavity you have the lungs, a pair of lungs is there. In between the lungs the heart is located. That location we call it as mediastinum, and it is well protected inside the bony cage. A bony cage protects our lungs as well as heart, and it is reddish brown in color. Next we are going to learn about the layers of heart. Heart is divided into 3 layers. Number 1, pericardium, and middle myocardium, and finally the innermost endocardium. Pericardium is a double layered. For example, this is the pericardium, means we have 2 layers of pericardium membrane layer. In between the 2 membranous layer you have a space. That space we call it as pericardial space, and this space is filled with pericardial fluid. You need to know why this pericardial fluid is present in our heart, that is in the space of pericardium. Why it is present? You know why? Because heart always pumps the blood throughout the body. Okay, it is a tireless organ in our body which works, and it contracts and relax for several times, and even till our death. So it is more important. So heart keeps on pumping our blood in our body. Because of that, it will create some friction over the internal organs, and also within heart also it creates some friction. So that friction should be avoided. That is the reason why we have pericardial fluid, so that it acts like a shock absorber and to avoid the friction. Next we will learn about the chambers of heart. It is 4 chambered in the case of human being, and it is 2 in the case of fishes, and it is 3 in the case of frogs. Okay, we have 4 chambered heart. There are right atrium, right ventricle, left atrium and left ventricle. Out of these 4 chambers, only 2 chambers are smaller in size, and the other 2 chambers are larger in size. The smaller chambers are placed in the topmost part of the heart, and the larger chambers are placed in the below the smaller chambered heart. That is the below the atria we have these ventricles. They are right atrium and left atrium are smaller in size, and the rest of the 2 are larger in size, and they are placed below the atria. Next we learn about the important blood vessels of heart. Basically we have 2 types of blood vessels. The one type which collects and supplies only the oxygenated blood, the other type which collects and supplies only the deoxygenated blood. Here we have 4 blood vessels which are present. One is pulmonary artery and pulmonary vein. Vena cava, again it is subdivided into 2 types. One is superior vena cava and inferior vena cava. What is superior in vena cava and inferior vena cava? Here this vena cava, that is superior vena cava, collects the blood from above the heart. For example, from above the heart means we have brain, we have face, eyes, all the sense organs are present above the heart, and below the heart also we have some organs like abdomen. Inside the abdomen we have stomach, intestine, and inside the pelvic cavity you have certain organs in lumbar region. So many organs. This animation illustrates about the single cardiac cycle. It starts on the right side of the heart. The reality is, of course, the 2 sides of the heart will work together at the same time. It is easy to understand if we study them separately. The cardiac cycle begins when the deoxygenated blood flows from the body in the right atrium through the superior vena cava and the inferior vena cava. In the next phase of the cycle, the right atrium contracts, pumping the deoxygenated blood to the right ventricle through tricuspid valve. Once the right ventricle fills with the blood, the tricuspid valve closes, preventing the backflow of the blood. The right ventricle contracts again, forcing the pulmonary valve to open as the blood is pumped in the pulmonary artery. The blood is then travels to the lungs when the pulmonary valve closes. At the same time, the right atrium relaxes, ready to accept the next intake of blood. In the lung, the blood picks up the oxygen and releases the carbon dioxide. Oxygenated blood from the lungs flows into the left atrium via pulmonary veins. The left atrium contracts again to pour the blood into the left ventricle through the bicuspid valve or the mitral valve. Once the left ventricle is filled with the blood, the bicuspid valve closes. Next, the left ventricle contracts, forcing the aortic valve to open, allowing the blood to be pumped into the aorta, and from there to all parts of the body, and the aortic valve closes to prevent the backflow of the blood to the left ventricle. Now the left ventricle relaxes and ready to accept the next intake of blood. Now the cardiac cycle is complete.